products. What are these called? These are called di-substituted products that we get on further substitution of this mono-substituted compound. Now, which one will be the major product? That is decided by this factor, this functional group which is present over here. Since we are dealing with haloarenes, so we will be taking into account the effect of this halogen group that is attached with the benzene ring. Beta, the product that we get depends on nature of this substance, nature of X decides the position of incoming group, decides the position of incoming group, and this particular property is nothing but it is known as directive influence. This is known as directive influence. What is directive influence? Let us take it with an example also. Suppose there is some function. In that function, position of guests, chief guest, press, media, everything is decided. Somebody is there at the entry point who directs the incoming group to their respective position. Same behavior is done by this group which is already present in mono-substituted compounds. That is, they will direct the incoming group. अब जो second आएगा उसको ये बताएंगे कि where they have to go. In benzene ring, total 3 positions are there. The adjacent ones are known as ortho. The alternate ones are known as meta, and the opposite one is para. That means there are 2 ortho positions in benzene ring, mono-substituted compound, 2 positions called meta, and only 1 position called para. So, इनमें से where this incoming group will be directed, that is decided by this group which is already present on the benzene ring, और इसी को हम directive influence कहते हैं. Here we are going to deal with the directive influence of this halogen group in mono-substituted benzene compounds. Now, कहाँ direct करेगा? तो first let us see who is coming. So who is coming is an electrophile. Electrophile. What is electrophile? Electrophile is electron-loving species. Electron-loving species का मतलब they themselves are electron deficient. खुद के पास इलेक्ट्रॉन की कमी है. Therefore, they are in search of some electron-rich species, electron-rich sites. इसका मतलब बेंजीन रिंग में जहाँ जहाँ भी इलेक्ट्रॉन डेंसिटी ज़्यादा होगी, there this incoming group will be directed. कहाँ वो जाएगा? तो अब हमें देखना है कि in presence of this X, where the electron density in benzene ring is higher, at ortho position, at meta position or at para position. और उसी को हम some resonating structures के through देखेंगे. तो let us find out where is the electron density in benzene ring higher. So before that, let me take, if I see X, then X due to minus I effect, that is tendency to attract electron density towards itself. Due to this minus I effect, it is electron withdrawing. If it is electron withdrawing group, that means ये benzene ring में से electrons खींच लेगी बाहर, electron density को बाहर खींच लेगी. So we call it deactivating group. Benzene ring deactivating group. Benzene ring deactivating group. But there is some special feature of these halogens. What is that? It has got lone pair of electrons. And because of the presence of these lone pairs, it can give its lone pairs to benzene ring. अपने lone pair benzene ring को दे सकता है. And this is called resonance effect. It has got two effects. One is called the inductive effect that makes it deactivating group. Benzene ring से ये इलेक्ट्रॉन खींचने की कोशिश करता है, but because of resonance effect and which is more dominating, it increases electron density of benzene ring and that is now going to affect the directive influence. उसी के according हम इसका असर देखेंगे कि what effect does it have on the benzene ring. So let us move to our next topic, that is what is the directive influence. So directive influence is because of resonance. Due to resonance effect, it is going to affect the electron density. Let me make diagrams. It can be easily understood with diagrams. Diagrams में I hope हम सबको एक चीज पता है. A bond represents an electron pair. A negative charge represents an electron pair. An electron pair can shift from one position to another. This is called electron displacement. तो हम ये electron displacement करेंगे और हम देखेंगे कि इसमें कहाँ पर benzene ring की electron density change हो रही है. First, let me move this lone pair to this point. Since from X, lone pair is shifted to this bond, so this becomes a double bond and X gets a positive charge. वहाँ से electron हटा है, shift हुआ है. Therefore, this gets a positive charge. And simultaneously, क्योंकि यहाँ पर कार्बन की वैलेंसी 5 हो जाएगी, so to change that, this double bond shifts to this point. Be very careful with the arrow movements and these are very important. Resonating structure हम इस तरीके से बनाएंगे. तो what resonating structure do we get? We get जिसको हमने change नहीं किया है. Please do not make a change in that. So this double bond remains intact. This double bond remains intact. What comes over here? Double bond. Then this X and what is there on this X? A positive charge. And this gets a negative charge. So appearance of this positive and negative is there. Now what is this position? Negative charge means electron rich. Negative charge means electron rich point. And where is this electron rich point? इसमें हम find out करेंगे. Now next, this point electron density may shift over here. With that shift, this will come to this place and let us make it again another structure, another resonating structure. So what is that next structure? Please do not make the changes where we have not touched. This remains intact. Now this becomes negative. This negative shifted to this point and then it was exactly same, no change in this position. I hope this is quite clear. After this, again there will be movement. This negative charge makes a bond over here and this bond shifts to this position and the next structure that we get is this one. No change in this position, positive charge. This becomes negative over here, a bond over here and this is intact. Another resonating structure. What will be that? This double bond shifts to this place and again it goes back to that. So what is the final structure that we get? The final structure that we get in this, no change. Here we get the double bond now. This double bond shifted, so it becomes single bond. And since now electron pair goes to X, तो वापस उसका charge cancel हो जाता है and we get this structure. I think this first structure and this last structure are exactly same, but only the double bond position interchange. वो change हो गई, that is due to resonance. Now in these resonating structure, can you please locate कि where there are electron rich points? That means कहाँ पर negative charge present है. So we can easily see negative charge is present on this adjacent position. mono substituted compound is ortho para directing. दोनों compounds बनेंगे, and out of these two compounds, what are the major products? Due to symmetrical reasons, the major product comes out to be para product. Para products are the major product. So this is about the electrophilic substitution reactions in which the products are ortho and para directing compounds. I hope this directive influence of halogen is quite clear. In our next class, we'll take up those